Hello everyone. We'll start in a couple of minutes. So let's just wait for a few more people to join. Let me start the recording. Also a YouTube channel. So all our sessions recordings are available there. Our past sessions recordings of Azure Singapore and data community and AI ML community. So if you are interested in very nice sessions of different topics, so you can just go and subscribe the YouTube channel. So and before start, I will just wait for I think Lohith is also there. Hi Lohith, you're there?
I'm here.
Great. I'll just do some announcement and then you can just take over.
Yes, sure.
Thank you. Let me make you presenter. Okay. Okay. So we are. So if you want to, if you are interested in presenting any sessions, or if you want to organize, it's like if you want to connect with any one of your organizers, so you can contact any one of us, and we are some of the organizer for Azure Singapore group. So we'll help you to connect for other communities as well if you have any questions or queries. And for the next, we have done a couple really nice sessions in the past. So there was a means DevOps series we have done in December. So if you are interested to know more about it, like how to work with the DevOps and all, so it's all the session recordings are available on our YouTube channel, and you can just type the Bitly link as your Singapore sessions. And for today's sessions, Lohit is actually this month we have planned for doing API building series. So this is the third part of the series, implementing the API. In part one, Lohit have explained how to design the API and miss if you are a complete new, so how you can design the API and do all things. And the next, he have explained about the DevOps, how you can implement the DevOps for the API building, and he have explained the nice tools of Plumi and some other tools. So you can just go and take the look of recording of the sessions, which is available on our YouTube channel. And there'll be also for part 4, which will be on March 4. So implementing the consumer. So if you haven't registered, so please go and register on our meetup channel, meetup group. So this will be on March 4th. And some related sessions means like if you are interested in API and microservices, so we have done some related sessions in past. So these sessions are also available on our YouTube channel. You can just go and take a look there. And this is we have already published the part 4 link on our meetup group. So you can just go on meetup.com, and there is the Azure Office Data Community. So there is a part Serverless Architecture Real World Application part 4. You can register for that, and we have also provided the link of the session which we have done in part 1, part 2, and part 3. So all the recordings, YouTube links are available in details of the meetup. And there is also one Singapore Power Platform boot camp is happening on this Saturday, 20th February. So if you are interested in Power Platform, I think this session, because there might be a couple of sessions for this is a whole day event, so there might be very interesting sessions, so you can join there. And this is our YouTube channel, so all the sessions recordings are available there, so you can just go and take a look there. And these are some chartbuster sessions we have done before. And before taking over to Lohit, so there are some reminders. Please keep yourself on mute. And if you have any questions, please raise hand, or you can also put in the chat box. And this session is being recorded. And if you like the session, please help to spread the words on meetup group or Facebook and Twitter. And for the Lohit, I think Lohit is he's a tech lead in Xamarin, and he's also ex Microsoft MVP and a tech evangelist on Telerik. He have written a couple of nice books on the .NET and technology. So, and he having more than 2 decades of experience on .NET. So yeah, over to you, Lohit.
Well, thank you. I think it's getting recorded. So good evening. I'm in Singapore, so it's evening time for me. So I hope most of you guys are joining us from the APAC. It's also evening for you guys. So if you, as Asif said, this is the third part, as we call it, in the real world. Oh, I've not shared my screen. Sorry about that. Let me share my screen. Yeah, so you guys should be able to see my screen now. Yeah. Okay, so this is a 4-part series. We wanted to see how we can let you know on the serverless side of Azure, which is Azure Functions, how can you build a real world end-to-end, which includes, I just have an idea, I want to build an API. Okay, so let's start with specification. So that's the part 1. In part 2, from specs, we looked at how to go about DevOps, meaning typically, if you're coming to this session for the first time, so these are all things we did. We did not do the implementation of the API in the part 2, but rather in my company, in my teams, what we practice is the moment we have a spec, and then what we do is we just do a bare bone file new project. Once the file new project is done, we straight away jump into DevOps to create the infra, to create the pipeline. Why? Because once it is there, then as a team, I just keep checking in my code, and then I'm rest assured that my code is going to go and sit in my environment. Because if it works in the environment, that's the ultimate test for us. So that's what we did in part 2. In part 3, we're going to be looking at some of the things that you can do with Azure Functions itself. Is my screen visible to everybody?
Yeah, we can.
Okay, cool. Yeah, we can. So this is something that about me. I'm been on the Microsoft.NET for 2 decades now. I'm currently working as a technology lead for Xamariners Limited. I'm also an ex-Microsoft MVP. I've been an MVP for 7 years. I also worked as an evangelist for Telerik in India. Yes, and then these are some of the books that you see, and then I keep speaking in many, I've spoken in many events, and then I'm now here. Thanks to COVID, we can all present from our home, so that's what I'm doing. This past 3 part series that we have done. So far in the series, part 1 was designing the API. We looked at Open API and OpenSpec. So the video is already out. The recording of the session is available on MSSGUG YouTube channel. So YouTube take a look at that. Then in the part 2, we did the DevOps for our API project. We created the infrastructure using Pulumi. Pulumi is an infrastructure as a code framework. Lets you build infrastructure as a code using C#, the language that you know. So this idea originated from we wanted to showcase as if like using C# on the serverless side of things. How can you go full stack on C#, right? Starting from generating the spec to DevOps. You use of course, your code is C# for the functions, but DevOps also you can do C# using C# you can do the DevOps too. You can do the DevOps as a code can be done using C#. That's what we did in part 2. In part 3, this is all about implementing the API. I'm not going to run through slides, but rather open up the core and then talk through what I think we do in our company and in my team, and then maybe that is helpful to you guys, beneficial to you guys. So that's what the whole intent of this series. And then the part 4, we're going to be looking at how to implement a consumer. Now I build the API. How do I do the consumer? So DevOps is C# using C#. Implementing the API is using C#. Implementing a consumer is also going to be using C#. Because I'll be showcasing Blazor. Using Blazor, you can build single-page application using C#. So the whole idea is C# with .NET and Azure. How you can do full stack serverless using I call it as full stack C# serverless because serverless is a very broad terminology. You can do serverless using TypeScript, meaning if you go the route of Azure Functions, Functions itself supports many languages. So I'm doing C#, but you can do TypeScript, you can do Python. Not only that, you can do functions using PowerShell. If you are a PowerShell developer, and then you want to build a serverless API, Azure Functions allows you to do serverless APIs using PowerShell. So in this case, we are using C# as the language because I'm a C# guy from last 2 decades, and then I don't know anything else. So using C#, I've already built the infrastructure as a code. Using C#, I'm going to be implementing the API, and then using C#, I'll build the consumer. So just to take a quick recap on where we left off, I'm going to go to my GitHub, and let's pick up the repo. And this repo is MSUG webinar. What I'm doing is I'm having different branches. If you see here, I'm currently working on part 3, which is implementation. But in the part 2, let's take a quick look at what we had done. We used the OpenAPI spec. The OpenAPI here, the way the folder structure is done is you're going to be having a folder called infrastructure. So it basically has everything to do with infrastructure. Then pipelines. That's the CI/CD pipelines. I'm using GitHub as a repository. but I'm doing all the the CI/CD on Azure DevOps. So my DevOps is here. I have a project called MSUG webinar under my own organization on DevOps, and then I'm just doing the pipelines. I don't have a repo, but all the pipelines are here. So in part two, we finished the infra pipeline and then infra state pipeline. Well, if you're wondering what is infra pipeline and infra state, I recommend you go see the part 2 video. There we went through everything. Basically, we used Pulumi. We create a state infrastructure to maintain the state of Pulumi's state, and then the infra pipeline itself is nothing but we use Pulumi to create the infrastructure in Azure. So as part of part 2, we have already created a resource group. It's called as RG to do API Dev. And inside the resource group, we have the plan, app service plan, we have the function, we have the storage account required for the function. So that's what we finished in part 2. And as part of part 1, we created a specification. That's the OpenAPI YAML. So this is the spec that I'm working on. So if you're here for the first time, so let me just put a the problem statement. The problem statement is very simple. You are an API. You are part of the API development team at Contoso. You are tasked with development of an API to manage employee to-dos. Here I picked to-do as an example because it's the simplest one that I can talk about. The focus, the main objective is not the to-do API itself. It's just a hypothetical. You can think of this as an hypothetical example. But what I'm giving as part of this 4-part series is things around this whole requirement, right? I have a requirement, but what's the best way to do a real-world end-to-end applications? Yeah, so the surrounding things, your requirement, that's what is important. Like, where do we start? This is my requirement. We started with OpenAPI spec. From the spec, we went into doing a DevOps as the first step in implementation, not the code, but getting our DevOps pipelines ready. And doing DevOps, we use the Pulumi and then the C# to create the infrastructure. So now, in the part 3, I'm done with my DevOps. I need to implement my API. My API is not yet done. What we did in part 1 was we looked at certain tools which understand this particular OpenAPI spec, and then they can spit out some code. So if you go into the SRC in the source folder in the part 2 or even the part 1, designing the API, let me go back to part 1. And then if I open up the source folder, we have a to-do API folder. Inside this, we have a class file called todos api.cs. So this is auto-generated code from AutoRest. We used AutoRest. AutoRest reads the YAML and then generates the C# file, right? But I'm not a big fan of, so whatever I'm saying here in this 4-part series is completely my experience over last 2-3 years. I've been doing completely serverless. I have in my company now, I have a big platform which is running out of 16 serverless Azure functions. So whatever I'm saying is kind of my preference, my way of doing things, but it's opinionated, as we call it. You may find like, no, I like what the AutoRest did. By all means, I'm just saying what works, what has worked for us, because we are a consulting firm, and then, well, I need to have a customer. I have a customer who I need to please. So, and then plus I need to make sure his platform is running fine. So these are some of the things that we did. When you go ahead and then use AutoRest, give it an OpenAPI spec, what AutoRest does is it creates one single class and then starts putting the functions, all the function endpoints that you provided into one. Yes, in our case, we have only one area, as we call it. That's the to-do API. And the to-do API has maybe 5 endpoints. So when we generated the spec, what AutoRest did was it looked at the spec and then it treats the spec as a class, and that's to-do's API. And then whatever endpoints we defined in the spec, well, it just goes ahead and then starts creating functions on them, right? These are all nothing but the endpoints. So let me open up the OpenAPI. Hang on. So let me bring up Visual Studio Code, and then it's going to be even better. So I'm going to bring up OpenAPI, and our spec is here, right? So I have an extension here, which is OpenAPI. Notice here, I have this many paths, right? So I have a slash to dos, and then I am doing a get on the slash to dos. I'm doing a post on the slash to dos, and then I also have to do slash the to do identifier. So I have a delete on the to do identifier, get on the to do identifier, and then post on the identifier. So I'm having 5 endpoints. So what Autorest did was all the 5 endpoints have been has been converted to a function, which is what serverless is all about. Every endpoint becomes a HTTP trigger serverless Azure function. So this you can see it here. It will say that this is a HTTP trigger, meaning somebody needs to invoke this endpoint. That's fine. But notice what has happened. I'm having all the 5 endpoints put into only one class file, right? Typically, we don't follow this way of doing things. What we do is we create separate class files for each function. Why is that? Well, it's just for the simple sake of simplicity and then maintainability. When I have uh, with Azure Functions, one endpoint is equivalent to one function. So if I have a one endpoint having problem, an exception, or the QA says like, hey, this endpoint is not working, it's very easy for me to just ask them like, okay, which endpoint is not working? Okay, endpoint equals function. Okay, I just open up that class file and start working on that. So that is what I did. And not only that, notice here, when Autorest generated the project, all it did was it just gave me the to do what do you call the model, and then it gave me this class file. That is all it gives me, nothing else, right? And in order to be a good API, well, good development practice also, this is not enough. Gone are the days where I'm creating the objects using the new syntax, like you say some variable is equal to new, and then you instantiate your dependencies. I don't remember when was the last time I did that. Why? I'm using the I and D of the solid principle. I hope everybody knows the solid principle. So I stands for inversion of control, D stands for dependency injection. So if you are on ASP.NET Core or you are on .NET Core, and the .NET Core is built with these things in mind, which is you can do inversion of control and then you can do dependency injection. Why? Because .NET Core has a small dependency injection container. Using that, we could do the inversion of control, and then we can inject the dependencies, right? So over the last 2-3 years, ever since .NET Core has come up, well, we have also, at least for me, I've stopped newing up my dependencies. I set up my container right from the start, and then put all my dependencies in the container. And wherever it is required, we just say like, hey, look, I'm dependent on this particular service. I need that service. If it is not there, I cannot function. So by doing that, I'm making my intentions very clear as a class. For me to exist, for me to behave, I need my dependency met. If my dependency is not met, I cannot function. So upfront, I'm putting my expectations. So that's what I'm used to. But if I use Autorest, well, it is not giving me anything. Fine, it went ahead, it looked at the spec, and then it has put everything very good. Like it says like, hey, look, spec defines HTTP 200, so please handle the documented response. Spec defines 2001, and then spec defines 405. 405 is like, I'm expecting a input, and the input is bad. So I'm just throwing up maybe 405. Maybe it's a, whatever things I need to handle. For example, 200, 404 is not found, 400 is error, 200 is okay, the execution is fine. So Autorest has done some work for me, and that is helpful. But from here, I need to pick it up and then make sure that I have a pretty good architecture in terms of my particular Azure function project. So in the part 3, that is what we're going to say. We're going to do. Take from where Autorest has given us, and then change it according to the best practice. So let me bring up my code base. So what I did was, I think my Zoom percentage is 200. This should be visible, I mean, legible on your screens. If not, do let me know
Yeah.
through chat or anything, and I can bump up my, the font. If it is clear, it's fine. Otherwise, I can bump up.
Yeah, it's clear.
Okay, that's good. So the first thing that I did was I split up everything what you see. I mean, what we saw in the class, which was like one single class with 6 different functions in it. I split it up into 5 different functions, and I follow a convention. We all know that when you have to name a class, the class has to be named as a verb, correct? I mean, sorry, noun, right? So you could do like to-do list function or to-do listing function. So my intention is very clear. In my team, we follow this convention. The first prefix of your function is usually what module am I on? So in this case, I'm in a to-do API. So I would say like, hey, yeah, you're in to-do land. Okay. The next thing we put is, okay, what action are we doing on the module? Oh, we're listing the to-do. Okay. So the function name, we're going to change it to to-do listing function, right? That's very helpful. If I'm looking at a code base, reviewing a code, or 1 year down the line, I come in, I know the name itself strikes to you, immediately that you say, this is to-do listing function. Oh, cool, I understand, right? And then don't worry about the dependency yet. We'll come back to this dependency. But the next thing that we need to look at is, yes, I do have a constructor, and then that's it. You just put a function. You stick a function in this class, and then now I become the functions runtime will look for anybody who is annotated with this attribute. The attribute is function name, right? So this is a way to tell the function runtime, like, look, I have a function. I need you to expose this to the outside world. That's all we are saying by this particular attribute. And another thing that we have been following in our company is wherever we need to use a name of the class, like the string, right? So typically, if I go back to what autorest did, notice here function name, and then it is putting a string. And whatever you put here is very important. Why? Whatever string you give in the function name, when you deploy your function to Azure and you go inside your function app, there is a section called functions. You see this name here? This name corresponds to whatever string you are given here. I think I cannot say this enough in my team. Like, I'm very, very particular about naming. If you got the name wrong, I'm gonna reject your PR, and then we're gonna let you redo your PR, and then like we have fights over the name. Why? Because once you go production, you know what? You cannot change these names, right? Now, if I'm in a production also, and then let's assume somebody goes in here, they have very clear-cut naming terminology. These are all the functions, then these are doing this. So this is to do create, to do delete, to do listing, to do read, to do update. Cool, I get it. Even if you don't know technology, the moment you see this, at least the naming convention will be like, this is a function, it is doing this particular action on this particular module. Well, that's what you're trying to aim here, right? So autorest goes ahead and then does its job, and it is doing based on certain algorithm, which is like, this is the I think I gave this particular name in the spec, and then I'm doing an HTTP GET on that. So it uses whatever ID you gave, and then list to dos is the ID I gave. It adds async because, well, in C# and then in .NET Core, it's a convention. We all use that. If you're an async method, you got to have a suffix called async. That's a best practice or better practice that you should follow. The moment you have an asynchronous method, stick an async to the end, so that if somebody is consuming, they know that this is async, and then they need to await on that. So that's the main purpose of that. So now, if you made a mistake in putting this string, it passed your review, because sometimes your eyes plays a lot of games, right? You think like you're looking at it, and your brain and eyes are like, yeah, the string is correct. Go ahead. There's no spelling mistake or whatever. But maybe you misspelled to dos, or you misspelled something. If you did not catch it till production, it's going to be too late, right? So that's why what I mandate is this function name needs to be your class name. So that is what we are doing in this one. If you see here, there is a reason why I named this class like this, to-do listing function, so that I can make use of C# 8 name of functionality and then say like, look, the function name is the name of this class name. And we have been doing this in most of the code we write. Wherever we need to do caller name, callee name, function name, class name, well, we make use of name of, and then callee dot. There is a whole bunch of things available in the C# 8, right? So now, once I've done that, you can name this function method anything you want. I can call this foo, doesn't matter. Why? Because in the world of Azure Functions, what matters is this function name. That's the HTTP endpoint, and then this function has a route, and the route is usually defined on this trigger itself. Notice here, we are saying this is a HTTP trigger. At this point of time, for the demo purpose, I'm using the anonymous authorization level, meaning anybody can get into my function. And I'm saying this function can be invoked using HTTP GET. And then the route it should be invoked is, well, it's something like API / the user email address / to-dos, meaning the employee / his to-dos. So that's the idea of that. And then because I'm using this placeholder, this is a very special syntax or a special pattern, as we call it, the route pattern. The Azure's function runtime is capable of looking at it, parsing it, and then filling it up into this particular variable. It's pretty similar to what ASP.NET Web API route parameters do. It's basically the route gets mapped into your model binding is what we call it. So that's what it is. So similarly, what I've done is I've gone ahead and then did everything. If you see here, to-do create function, function name of to-do create function. This is a create async. The route is to-dos, the anonymous, this is post, all those things, right? Now, I've gone ahead and then I've done the same for everybody. I just split it up, and then you notice that I've not implemented anything because, as I said, the implementation of this particular logic, well, it's left to you. I mean, basically, you can implement it in any ways. You can do a static list, or you can connect to a database. It's of secondary. It's of no. I mean, it's not of the prime importance for this particular thing. The things that we are interested in is, one is naming your function, the class, what we are looking at very appropriately, so that this name is what you see in Azure when you deploy. That's the first thing. When you go read up your documentation, well, there probably is one liner where it says like, oh yeah, this is the name of the function, but how does it relate? Where does it work? Well, it comes through experience. So when we started out, when we wanted to just get started with this is what we did. We just put some name, and then we're like, oh damn, why is the name coming like this? Oh, that's because we gave it there in the function name. Okay, let's stick to a convention. Let's stick to a standard. And we have been doing this standard for all the APIs that we do. We pretty much do a module, a verb, and then a function. It basically needs to be a verb. So to-do read function, that becomes a noun. If you just had read, well, that's a verb. So that's why the method is a verb. Read async, that's reading asynchronously. That's the action I'm doing, or the verb I'm doing. So these are some of the things that you as an architect, or you as a team, or you as a lead, well, you will need to stick to these things right from the get-go. Why? Because typically what I've seen is everybody's like, yeah, I know what I need to do. I just need to create a class. Okay, they will go put A, B, C, or foo, or bar, or whatever name. And then finally, when you're about to go, like, I think the name is not right. Let's change the name. You will redo your stuff. Instead, you stick to your conventions right from the go. Don't go into the coding level at all. Just stick to convention. How are we going to name a function? What are we going to do with the method name? So all those things, you just stick to that. So that's the first thing that I wanted to talk about, because this is something that we follow meticulously in our team. Second thing I've noticed is, notice here in the Azure function world, you can have your own configurational settings. Like now, of course, who does not have a configuration setting? Basically, every function needs certain config keys and then the values for that. These two we don't need to worry because by default these two will be taken care by the infrastructure. So if I have to show you my infrastructure, let me bring up my infrastructure, and it is here. So what I did was, when I'm creating the function app, if you see here, create function app, the infrastructure of the function app itself will take care of putting what is the storage account it belongs to. So it is putting the key value pair, the job storage. Well, this is the value, the Azure Web Jobs dashboard. This is the value, and I'm trying to kind of provide a hypothetical situation wherein like you need a connection string for your application, right? Now the infrastructure does not store the connection string anywhere. What it does is, let's assume we have created a Cosmos DB just before creating the function app, just a hypothetical case. I've created the Cosmos DB, and because the Cosmos DB infrastructure is created, well, it will have its own connection string now. So what the infrastructure does is, it knows what the Cosmos DB is, and then it just goes ahead and says, hey, function app, you have a config key. The key is to do DB connection, and then your value is so on. So this all happens on the runtime when you run your infrastructure IAC code, right? Now the infrastructure is created. Now we are in the implementation stage. So in the implementation stage, I'm a developer. I have my laptop or a desktop, and then I need to develop it locally. Correct? Now, what do I do for my to do DB connection? What's a regular practice that you see, right? Well, this is a config file. I've seen, or even in my team, some of the new developers, the junior developers, what they do is they, by mistakenly, they put a connection string for the dev environment and then check in the code. Okay, it was very hard for me to tell them like, look, this is a connection string. It can't be in the repo. You cannot check in this value into the repository. So what do we do? Right? That's the question. That's a valid question. So now what happens is in Azure serverless Azure Functions world, in order to do local development, the runtime is built in such a way that if you place a local.settings.json, the Azure Functions host and the runtime, they look at this, sorry, not the host, the runtime looks at the local settings.json and injects the whatever keys you have in the values, it injects to the the host as an environment variable, and the configuration is built, right? But just because Azure is doing, the runtime is doing that, it doesn't need you as a developer to put your connection string here and check into the repo. No, you don't need to. This is a practice that we do. Sometimes we also are like set in CI/CD. We use this practice. Why? Well, when I'm checking in my code, I'm not putting the actual value, right? So at this point of time, for a developer, we say like set in secrets. That means, hey, look, if you're working on this code base and you want to debug this locally or you want to run this code locally, you need to first set your secrets. What is a secret, right? Well, the moment ASP.NET Core, .NET Core came into picture, Microsoft, and for ASP.NET Core, Microsoft has brought in a fantastic feature called user secrets. I'm not sure how many of you are following it. In my team, this is the first thing that we set up. I make sure my team follows this to the dot. Like, no, if there is a secret, you're not going to check in the value to the configuration files. You need to generate your own user secret. So how do I generate my own user secret? Very simple. If you are on the latest Visual Studio, what you need to do is right-click on your solution, and you will now see Manage User Secrets. Let me stop it for a while. And I'm going to bring the Solution Explorer. Right-click and say Manage User Secrets. Boom. I get a file. And the file name is secrets.json. Well, it is a secret, right? So that's why it's a secret.json. But your question may be like, where is this file? You said secret.json. Is it in the project? No. That's the beauty of it. This file is not stored in your repo. It's not stored in your project. This is my secret in my laptop, in my desktop or wherever I'm working. So if I right click on it and then I say like open containing folder, there it is. It has taken my app data, roaming, Microsoft, user secrets, and for this project, it goes ahead and then pretty much generates a new GUID and then just puts a GUID as a folder and then generates my secrets.json. And now all I need to do is put this where whatever value I need to connect to, put it, forget it. Right? I just have to put the value. So what I've now done is I put a value for a local connection string. This is my local development Cosmos DB or whatever. It's of no, like the importance is not what I have, but the importance is the mechanism. I cannot emphasize that this much. Like, you got to change the way you guys work. You got to make use of all these things. These are the best practices that is out there. Never ever check in GUIDs. Never ever check in any secrets to your configuration, to your repos. Put it into your secrets. You want to change it? Go change your secret. Don't change your actual value and check it into your repo. So now, as you can see here, to do DB connection, it is set in secrets. And here is my secret. I've set a value, correct? Now, how do I use it? Well, you can use it using iConfiguration, whichever way you want it. Let's assume I want to go to to-do listing, okay? And let's say I want my configuration, right? There are a bunch of ways you can do it. I could just say like, look, I have a dependency on configuration. Please provide me that. And I'm going to create and assign a field. And let's make it underscore configuration, right? And then let's say I want to read the connection string somewhere. Can the keyword be placed in configuration file? I'm not sure what you mean by can the keyword be placed in the configuration file. Can you, Donna, can you like rephrase it or totally remove the config usage? Well, there's no way any application in the world can be completely done without the configuration. You need some amount of configuration. But if I'm understanding what you're asking for, yes, there is a way. What you can do is there's a very special syntax that you can put it into. I'm not sure if I'm set up for that, but I can show you that. Azure function config key value read from keywords. There's a very specific syntax. Yeah, keyword references. Okay, this is the syntax. @Microsoft.keyword. Within a bracket, you just need to put a reference string. The reference string is nothing but which is your secret and what's your version of the secret. That is all you need to do. Okay, then you can put all the keys into, in fact, that is one of the preferred approach that we do in our project. Basically, if you see here, yeah, this is what we do actually. This is the short format. So for example, I can take this, and this will work only on production, meaning inside Azure, for example, I can take this, go into my function, go into configuration, and then let's say for a moment, let's say this particular to-do DB connection, the value, I don't need to put the actual value. In fact, you should never put an actual value here. So what should you do? Well, just put this way, Microsoft.keyword, here is my vault, secret is this. Then what I do is I set up a policy on the keyword. Only me and my boss can go into the keyword and look at the secret. Nobody else can see the secret. This is the preferred approach. Well, today's example, I'm not doing it that way, but yeah, that probably is a good way to do it. Yes, it's super cool. We figured this out like a couple of years ago, and then from then onwards, we stopped doing anything, putting into this particular configuration as a value. In production, we always do this way. In production, we go ahead and say like, oh, go ahead, this is the keyword, this is the vault name, and then this is the secret. That's all we do in production. But locally, yes, I just set up my secret and then just put it. There's one more question. I hope, Donna, this answers your question. There's one more question. Let me take a look at it. Curious about secrets in Visual Studio. It is stored on laptop. Anyway, there is a need to pass those secrets to developer, usually external party, and he should not be able to know the secret. Currently, my practice, store those in keyword and set up in configuration of, yeah. So, yeah, so basically what Erwin is saying is, if I need to pass the values to somebody, well, we also have a mechanism for that, Erwin. What we do is, in fact, you should never share your secret. That's the first thing. But when you're in a project, you cannot help it. I have a new, let's say, a contractor, or I have a consultant who is working from some other third-party company, and he needs to start working on my particular project. So he needs to know the secret. Believe it or not, we never share the secrets through like Teams or sending through an email. No, we don't do that. What we do is, as a team, as a project, as a company, we have invested in what's called as a let me show you. We use what's called as one password. In fact, you're looking at my company one password now. So we use one password. We set up a guest profile and we set up vaults inside the one password. If you see here, these are all my projects. Okay, don't screenshot it, but these are all my project. Each project has a vault, and each project's vault contain all the secrets that is required. So if I want to share this with third party, all we need is we set up a guest profile in the one password, and we tell them like, look, the only way you can get the password is you set up the guest profile that I set you up. You set up your one password, and then that is the only way you can read your password. This is something that we do in our company. Everything related to the project is not stored on disk, is not stored, is not passed across as a notepad or anything. No, it is all stored in one password, and then anybody who needs to get a value, he just needs to access the one password. If you don't have access to one password, that is for a reason. You should not be seeing that secret. So that's what it is. So yeah, that's the couple of ways of doing the directly you can create a key vault, put all the keys into the key vault, and your application in Azure. This is the coolest thing that we have seen. Any configuration that you have, like Azure App Service or Azure Function, the moment you have a configuration, you can always go ahead and then reference key vault right from the value here, and then it picks it up. You don't need to know, you don't need to mint the value into this particular config key. Now, how does this work, right? So I was talking about the dependency here. So I just need to say that, look, I'm dependent on I configuration. Notice here in my secrets.json, I have my account endpoint. But if you look at my local settings.json, I don't have a value. So what I'm going to do now is I'm going to run a simple function here. And when the function runs, I'm going to say var connection string is equal to configuration underscore configuration. And then I know the key of that particular config, right? So that's to do DB connection, right? So that's all. Okay. Now I've put a breakpoint here. I'm going to run this. And because we have split this into 5 functions, now what you will see is when the function runtime starts, it will look at my project. And it is going to figure out like, oh, you have 5 functions, and all the 5 functions are running in this particular endpoint. Localhost 7071, API to do's, API to do's to do ID. This is a get, this is a delete, this is a post. Look at this. So now I have 5 endpoints, very neatly defined endpoints. What we started with OpenAPI spec, that's what this is. I've got it. Now I'm going to go and execute this to-do listing. So I'm using Insomnia. So let me bring up my Insomnia. Here it is. So now what I'm going to do is, this is the to-do listing, list the to-dos. So I'm going to put a send and then my breakpoint is hit. Now notice what happened. The connection string is able to get the value from my secrets.json. That's because Microsoft did a lot of things behind the scenes. Okay, behind the scenes, what they do is they'll see if there is a secret set up for this project. If yes, what they will do is they will inject the keys and values from the secrets into the environment, and then the configuration is built. And that is how it is able to figure out like, oh, look, you have a connection string in your this one. So this is the second tip that I wanted to give out. We follow this to the T, as we call it. Our projects are all completely set up using user secrets. We'll never do anything without the secrets.json. So the moment you right click on a solution and say manage user secrets, what it does is it does one additional thing. It adds a package here. This is the guy who is doing the magic behind the scenes. Okay, and not only that, notice here it now puts like, okay, for this project, the user secrets ID is this particular GUID. Okay, so now when you take my source code and you are a new developer starting in, all you need to do is just right click and say like, you know what, create user secret. It will create the same folder with this GUID, and you just need to make sure that you go to wherever the whatever is the value, you find the value and then just put it one time and you're done. Okay, that's the second tip that I wanted to give. The third tip that I wanted to bring in when it comes to project development, or especially .NET Core, is the concept of inversion control and then dependency injection. I don't think I have time today to talk about testing because your Azure functions can be tested. We do a lot of tests. We have like 300, 400 tests in our 16 API that we have written for a big customer. So, but in order to, if you have two different DB connection, how it will generate connection string? I'm not sure what what do you mean by two different DB connection? How will it?
Suppose if we have two different APIs for the create function, or maybe for the listing functions, I'm using two different DB, like maybe one Cosmos DB, one SQL DB.
That's up to you. It's nothing specific to secrets, or that's nothing specific to Azure Functions. Also, that's how do you organize your config keys. So for example, if you have to do DB connection and you use this for listing, then your listing function should always look for this key in the configuration. The read should probably needs to have another thing, like to do DB. Maybe you will need to name this as to do DB list. To do DB list, to do DB write, to do DB write.
Okay.
Like that, and then you will need to figure that out. Okay. The only thing that we typically do is we don't put the when it comes to dev environment, test environment, production environment, yes, the connection string will change. What I'm doing here with a secrets.json is a fourth environment. I always tell my team that, hey, look, this is your first environment. This is local environment. This is local environment. Not even dev. My dev is where? The dev is on the cloud. This is my dev. This is cloud. But this is so the first environment that we make sure it works is local environment. And for the local environment, we always put the local environment. Now the second environment that you will get into is the dev environment. For the dev environment, remember we have already done the infrastructure. So if you look at the to-do API infra and Pulumi, I have created the Pulumi dev YAML. Correct. And then the infrastructure itself will take care of putting the right connection string. That's what I was showcasing here. If you see here, I have a function called create Cosmos DB, right? And notice here, I'm giving a Cosmos DB account name and then a resource group. So how is the Cosmos DB account name created? Well, it is created based on the environment. This is Cosmos dash Cosmos API-dev. To do API-dev. If this runs in a test environment, then it is going to be Cosmos dash to do API-test. If it is production, it's going to be production. So that is what I'm saying. So I know where the confusion starts. It's like, okay, he just has one stack. How is this running? No. I've just created one stack called dev. But in a real world project, I don't have time to showcase all the stuff. I'm just trying to give you the bare bones. In a real world project, we will have two more stacks here. One is test. Another one is production. And if you notice here, I just have one variable. Which environment are you running in? If you're running in dev stack, it's a dev environment. If you're running in a test stack, this is going to become a test. Based on that, Pulumi will pick up everything. If you see the stack, notice here, I'm reading the environment and then I'm appending the environment to everybody. So that's how it prepares this specific environment resource. And in this case, when a Cosmos DB is created, well, it has its own connection string, and then I'm going to get that connection string of that particular environment. So different environments connection string is taken care using your infrastructure, not through your code. Okay, but for your question about, well, I'm using two different databases. Well, that's up to you. Then you will need to figure out how much you need. I mean, what keys do you need? Based on that, you will need to change your infrastructure. create Cosmos DB for listing, create Cosmos DB for rewriting, two different databases. You need to make sure your infrastructure is in place, and then it writes the appropriate value for that particular key, right? That's something you need to handle. Okay, so I think that's all the questions we have for now. Let me quickly start. We're already at 1 hour mark. The next thing that you need to understand is the DI containers, as we call it as function startup. I mean, if you're coming from ASP.NET, ASP.NET Core, the concept of startup is a big thing there. You configure your services, and then you configure your. You also configure which service to use. So ASP.NET Core is known as a modular framework. If you don't add a service and you don't say that you need to use it, ASP.NET Core is not going to give you that service. Very simple. It's very simple. In its simplest terms, ASP.NET Core is empty. You need to say that I need static file handling, I need routing, I need endpoint routing, I need this, I need that, and then you need to also say that, oh, by the way, I've added this service, please use it. So they go hand in hand. You don't do that, ASP.NET Core is not going to give it to you that. The concept of startup came up from ASP.NET Core and functions when it came out for the first version, V1. Yeah, there was nothing called as dependency injection or anything. We had to do what we all have been doing, which is like some variable is equal to new, the dependency class or something like that. Then around V2, I believe, they gave us this concept of, before your function app starts, before your functions are started, we can give you a hook. The hook is startup. By the way, this can be used only to set up registration. So registration means adding the services that I need. That's all. You cannot do anything else. You cannot do a logic here. This is only setting up your expectation. What I have done is, in a hypothetical world, let's assume that we are doing a to-do. So probably we need a service. So I've created I to-do service. Okay, a very simple interface. I'm big interface driven developer because it makes sense for me. I'm defining my contract, and somebody is implementing that contract. And if I want to test it, I just kind of go ahead and then test the contract, saying like, okay, look, the contract says list to-dos. Are you able to do that? Are you able to give me back an array of to-do items? So that's all I do. So basically, I put everything that we have, delete to-dos, read to-do, list to-do, async, all those things. I just put it up like that. As part of that, I have an implementation class. I call it as to-do service. It's I to-do service, and of course, I can bring in any backend implementation, like data store implementation, and then add it. I'm not purposefully put it because that's not of importance, as I keep saying. The importance here is you have a class, a service. It is implementing this particular contract, and then the only thing that I've done for now, just to showcase, is like, okay, you have a list to-dos async. What is it doing? Well, it is going to go to a database and then get a to-do for a user, and then just give you back the JSON, right? In this case, to-do item. Now, where should I use this? Well, I'm in a to-do listing function. The to-do listing function, well, it doesn't know anything except it knows a dependency called as there is somebody called I to-do service. They know how to get all the to-dos for you. That's all. That's my dependency. Now, for that dependency to work, first thing that we need to do is we need to create a class called startup. Then you need to add certain packages. One is Microsoft Azure Functions extensions. Then you need to add Microsoft extensions.dependency injection, because we are in dependency DI world now. These two make it possible for us to create a startup and then create a configure the services and all those things. This one is responsible for giving us the startup. If you see here, this function startup is coming from there. The extensions namespace. So what is it doing? Well, so what is it doing? You can create, does it need to be startup? Well, it's up to you. If you want to go ahead and call it Lohith, you can call it Lohith. Well, you can call it Lohith because I'm setting it here. Because so if you see here, we are saying that, okay, this particular functions app startup is contoso to do API.Lohith. But API Lohith does not look good. It's a convention. it's kind of a law. It's kind of a developers are started to follow, which is like, oh yeah, the startup should be called a startup. You know, it doesn't. Nothing else matters, right? It's a startup, so call it startup class. So call it startup and class. It inherits from function startup, and it has only one method that you want to override. Basically, there's one more. I don't want to talk about that now, but this is the prime important one, which is configure, and then you get something called as a builder. Well, this builder under the hood is having a lot of things going on. One of the things that provides you is this ICE service collection. This is the dependency injection container for me in .NET Core. Right? If you see the services, it's an ICE service collection. So what can I do? Well, I don't want to get into the lifetime of this scoping, the object scoping, the lifetime scopes as we call it. There is add singleton, there is add scope, there is add transient. You know, I would leave that as a homework for you to go figure out. But as of now, what I'm doing is I need to register a dependency, and that is if somebody asks for this contract, this is the guy who has implemented that contract. That is all I'm saying. That is all I'm saying. I'm registering my type against the contract and putting it into the DI container. Now this is the inversion of control. Then when I go to my to-do listing function, I'm doing a dependency injection. Right? Now I gave the responsibility of newing up to somebody. That's inversion of control. You gave away the control of newing up to somebody else. He manages how to new up things. Now inside the function class, I'm doing dependency injection. I depend on somebody who can implement, who has implemented I-to-do service. Please give me that when you instantiate myself. Meaning, whenever a to-do list API function is executed, and that gets executed when somebody hits this endpoint. Remember, we have this endpoint. Localhost 7071/API/ then I pass a user /todos. When somebody invokes this as a HTTP GET, this function is executed. When this function is executed, this class is instantiated. And it looks up the dependency container will look like, you need I configuration. Okay, I know how to give it to you. Oh, you also need I-to-do service. Okay, I can give it to you that. That's what it's happening here. So we are now doing dependency injection. And notice I never do new to-do service, right? That's the point. I never do the new to-do service. You always ask for it, and somebody gives you that particular thing. And then I'm just using it. If you notice here, underscore to-do service, which is nothing but to-do service, which is nothing but somebody implementing I-to-do service. And then I know that contract has a list to do. Please, here is a user. Give me all the to-dos for that user. That is all I'm doing. That is all I'm doing. In all our projects, when it comes to functions, we are heavy on this one. We don't do without this. Startup being set up and then we adding all our scope, whatever dependencies we have. You can add any dependency that you want. Let's say you want to bring in entity framework core, right? So you can say builder dot services dot entity framework Cosmos. So I'm using a Cosmos database. Let's say. And then you can say services.add DB context. Assume I have a DB context like what did I say? To do DB context, and then I can say something like this. So I can say service provider, and then options builder. And why do I need to do that? Because if you are working with any database, you need when the startup is you're registering your DB context, you need to know its connection string. So how do I get the connection string? The trick is a special lambda which gets executed at runtime. I'm going to get the ICE service provider. Because I'm getting the ICE service provider, I can say, I need configuration. So who's going to give it to me? Well, that will be the service provider. And I can say, please, can you give me the service called ICE configuration? There you go. And I need a connection string, and the connection string comes from configuration of to-do DB connection. Okay? Once I have then I can say options dot use Cosmos, and then I can pretty much notice here I need the connection string, right? So I can now say, oh, this is a connection string. And if I wanted, what I can do is I can go ahead and then put the database name also here. Let's say I'm gonna do to do DB name, and I think I called it as to do's DB, whatever, doesn't matter. So now if I want this, I could do where DB name is equal to configuration of. In fact, in my project, if my dev does it like this, PR is rejected. Why? PR is rejected. Never ever put a my thumb rule is don't I call this as magic string. Don't have this magic string. So what do you do? Well, basically you can create some constant files, like a file with constant naming, like something to do connection name, a key name or something like that, and then put it in one place. So that if I have to change it, I have to change it in one place, not like 100 places like this. This for the quick demo I'm just showing. Now I can pass the DB name here. Right. So now when I start, I'm not sure. Let me see. Okay. Let's see what happens. I think I need to. So it's not going to hit because unless I have somebody accessing the DB context, the DB context is not going to be created. So let's see if this is. Yeah. So it's not going to work. Basically, that piece of code is not going to be invoked. It's going to be invoked for the first time when a DB context is there. I'm not set up for the DB context. But notice here, I've got the to do service. Right. So it says, hey, this is a Contoso to do API services or to do service. It's giving me the implementation class, right? Now I can do an f-login. Now notice where I am. I'm in to do service, and this is the method where it's doing. So now I got it's doing. I don't need to worry about who is implementing I to do service. The dependency injection will take care of giving me that particular person who is implementing that contract. So that's pretty much. Now when I run this. Where did I run this? Yeah, there you go. So I have the output coming back. In this one, this is 200 OK. In this one, this is 200 OK. Coming back with all the identifier, like the JSON value that's coming out. Now, these are three things which typically you should take care. Other than that, like how do I access the database? How do I go and then do a repository pattern or whatever? It's the same. There's nothing new that I need to showcase it to you. But these are some of the things that we follow in our team. And then that's what I wanted to show. And then that's when I said implementing an API, I meant Azure function. What's the right way to do the implementation? If you look at your all the demos or probably the documentation, well, I don't think they're going to tell you to piece together. They will say, like, oh yeah, you can do dependency injection. Oh yeah, you can do configuration, but they won't give it to you in a full package, showcasing like this is user secrets, this is how you do configuration, this is how you do startup, and then this is how you do maybe splitting up of your function, naming the function, the class naming, the method naming. The method naming. Yeah, so that's what I meant by implementing the API. So this is now assume that your team is ready, and then you will start cranking the code. The next piece that's very important is now I built my code. Now my infrastructure is ready. How do I deploy my code? Correct? That's the next thing, right? So for that, what I've already done is I've gone ahead and then created a pipeline. And that's called as to do API, CI/CD pipeline. And I'm big on the naming. If you see the naming, the moment I see this, like, okay, this is the CI/CD pipeline. That's why I'm very big on the naming. If I look at it, I should know the intent of what is it being. To my juniors, I always used to give an analogy. I used to mentor kids who are just out of the college. So I used to ask them, what's the last thing that you did just before starting to the office? And he would proudly say like, "Oh, sir, I looked at the mirror, and I made sure like my hair is right, my collar is fine, my insert is fine." So I used to tell him like, if you write the code has to be the mirror. The moment I look at it, it should be like, this is written by Lohith, or this is written by Asif. The code should speak to you. So that's been my thumb rule so long, and I tend to impart that into my team also. So I'm big on this naming. So the only thing that I pick is names. Like, hey guys, let's change his name. Why? Because it makes sense 1 year down the line when I need to go back. So what I've done is very simple. This is the to-do API CI/CD pipeline. I'm set up the. So if you don't understand this, well, if you don't understand part 2, because this is what we did in part 2. It's exactly the same thing being repeated. I've just created a pipeline. That's it. Now the important things here is I'm doing .NET Clean. I'm doing .NET Build. I'm doing .NET Publish. And then I compress it as a zip file, and then I upload it as an artifact. That's the build stage of it. Then I need to deploy it. This is why I allow infrastructure as a code. Look at this. This is all it takes. I just have created a task. I mean, this is a stage called deploy. This is the development deploying to the development stage. And then if you see here, I'm downloading the artifact. I just published the artifact. I'm downloading it. Once I'm downloading it, I already have set up the Azure subscription. I just need to use this task called Azure Function App. That's it. It's a function app. The name of the app is to-do API-dev. The app name is set up here. If you see here, func to-do API, and then it appends -dev, and I'm saying the package is located here. It's a zip file. Done. My pipeline is done. The next thing that I did was I just went to my pipelines, and then I said new pipeline, and then it will ask me where is my pipeline YAML code. I pointed it to that, and notice here I have a to-do func app pipeline. If you see here, apps to do func app, right? So again, here also we follow a convention like to do func app. This is the to do function app CI/CD pipeline that we have. And if you look at the pipeline itself, it has 2 stages. I have a build stage, and in the build, it does a .NET Clean, .NET Build, .NET Publish. It zips the artifacts, and then it publishes the artifact. If the build stage is fine, then only deployment will start. In the deployment, it downloads the zip file, and then it is deploying if you see here, Azure App Service Application URL, func to do API dev Azure websites.net, and then that's it, done. So now I have literally finished my implementation, and my CI/CD is ready. So let's say I want to kick off a CI/CD, right? What should we do? Should we put something? Okay, let me just run it. So now I can just come in. I mean, of course, I have a trigger. If you see the trigger, I don't think I put a trigger. Let me see if I have. Yeah, I have a trigger. Anytime a code is checked into to-do API/SRC anywhere, this CI/CD pipeline will start picking it up and then start doing the build and deploy. You can also go and then stop the deployment if it is not a main. That is something that we practice. If it is not a version branch, or if it is not a main branch, in fact, we never release from main branch. In my company, we do a master or main, no more master. All the repos are now named as main. We have a main, develop, and a version branch. And we always release from version branch. Once a version branch is released, we piggyback it into develop. Develop is piggybacked into main. So you can actually put a condition saying like, deploy only when it is a version branch or something, whatever is your convention. But for now, for the demo, what I've done is every time you check in to this to-do API SRC, it's going to build. And if the build is success, it's going to deploy. Notice here, this stage called deployment depends on build stage. If it is green, it is going to go and then deploy. So what it does is it just goes ahead and then deploys it here. If you notice here, I have the function app, and I've already deployed it a couple of times today as a practice. So this is what you get. And I can also do from here, you can go and then do the, I don't know which version I have it on my cloud now, but you can always go and then do a test run from here, or you can take the function URL. If you notice here, here's a function URL, and then I can just go here and then execute it from here, whichever way you want. So from a part 3 perspective, I wanted to showcase those 3 main things that you do. But other than that, database activity, or how do you connect to a database, or how do you connect to a Cosmos? Well, you have plenty of conventions, demos available. You're smart enough to figure it out and then do it. But the other things is what is important, in terms of setting up a good serverless function code. That's having said that, I'm 13 minutes overboard. Probably that is all I had for part 3, the implementation. We already started with spec. From the spec, we generated the function code using the auto rest. Then we did a DevOps. Now we have finished the implementation of the API. In part 4, what I will try to do is I'm just going to build a simple client using Blazor, and that Blazor front end, the single page application, is going to talk to this API and then read the to-dos from this API and display it in the Blazor. So end to end, we are now using C#, .NET, and that's it. And then we can build this real world application using just these things. You have to learn only one language called C#. You need to know only one platform called .NET, and you can do DevOps, meaning infrastructure as a code. You can do single page applications. You can do serverless functions, APIs. That's it. So that's why I love the .NET framework, more than ever, just because of the functions. It's so easy to create an API. With that, I pretty much have done with for today. If there's any more question, well, I'm open for question. Thank you.
Hi everyone, if you have any questions, so you can unmute yourself and can ask, or you can put in the chat box. Okay, hi Lohith, I have one question. I was just going through the Plumi, so I just came to know that there is a way in Plumi you can encrypt the states. So means how actually we do that?
The state encryption is basically I will need to look it up. What they allow you to do is secret encryption. So what I've done in my case is, yes, you will have secrets in your stack, right? And then you don't want to see them, right? So let me quickly show it to you. Let me go to where's my infra to do API infra. Notice here I have this is the stack variable called env, and it has a clear text. Right. When I created my dev stack, I've already given it in salt, and this salt is known only to me as a team. Nobody else knows it. This is a encrypted salt. Right. The password is with me. Even if you know how to crack it, well, you can't crack it because the password is only known to me or to my team. So we put it into one password or whatever. Now let me go to command prompt. No, this one. Where is my? Just give me a second. Yeah, there it is. Keep looking in the background what's going to happen. So let me get into infrastructure and then to do API infra. Okay. Now I'm currently if I do Plumi list, it will say you have only one stack called dev. Okay. Sorry. Plumi stack list. Not. Hang on. Plumi stack help. There are a lot of commands, and then Plumi stack ls. Sorry. Plumi stack ls. So it will say like, hey, you have only one stack called dev, and that's the you notice the star there. That means this is the current stack. So typically in any given real world project, dev is not the only stack you will have. You will have a dev, you will have a test, you will have a production. So typically in your iteration, first iteration you do dev, and then you branch off. Your development is happy to use the dev. Then in your second iteration, your DevOps team will start saying, okay, in this iteration we're going to create the test stack. All they will do is they will say Plumi stack init test. That's all they will do. And then build a pipeline for that particular environment or whatever it is. Now, what Pulumi allows you to do is there are a couple of ways. One is you can use key vault and store a key inside key vault to encrypt your secrets in the Pulumi's configuration. So like for example, if I want to encrypt even this dev, I can tell Pulumi that look, your key is in key vault and here is the key vault reference. Okay. The simplest one is passphrase, as we call it. I've already set up a passphrase, and because of that, there is an encryption salt. And now I can say Pulumi config set. Let's say I'm going to say foo as a key, and then baz is the value, and I'm going to say secret. If I don't put secret, that's a plain text. Right. But if I say no, this is a secret. Notice what happens in the background.
Oh.
It did not write the plain text that I set. Right. So at runtime, meaning in the pipeline, yes, you need to make sure that you provide the passphrase. Otherwise, Pulumi cannot decrypt this particular config value. For example, let's assume I have my stack here, and let's assume I want that particular foo variable that I set up, right? Let's say foo. I will have to say config require secret, and then I will have to say the key is foo. But for this line to execute, it needs the passphrase. Because that's the salt.
Yeah.
Without the password, it can't encrypt it because the salt is that password. So for that, what I've done is I've already set up the passphrase in the pipeline. If you go into the pipeline and library, that is what I showcased in the part 2, which is like to create the variable group. And in the variable group, Pulumi config passphrase. This is a secret. Only the team knows. Not even anybody. Now that's the beauty of the Azure DevOps. Notice this is a secret. I have a lock here. If I unlock it, the secret is gone now. Meaning because you unlocked it, there's potentially somebody looking at it. So it won't allow you to use the same value now. You need to enter a new value. Meaning you need to enter the value. Currently, the value is there and it is a secret. Nobody knows, only except the team. So because I have this variables group here and in my infrastructural code, if I show you the pipeline, infra pipeline, I've said a pipeline. You can expect some variables from this group. The moment I say group and then I provide this particular variable group, Azure DevOps, all these keys that you have set up inside this particular variable group are injected as environment variables. So Pulumi gets it in the environment. And he sees like, oh, you have a passphrase. Okay, I'm going to pick it up and then I'm going to work on it. It's a fantastic world. DevOps is a, if you do step by step, it gives so much joy. I mean, I love, I'm doing a lot of these things now. I'm making sure my team, my company is moving away from classic DevOps tasks that we have and then writing everything into YAML. Why? We are in a consulting business, and then we have a situation. A lot of times wherein like people start with Azure, and then suddenly 1 year down the line they're like, hey, look, I want to move into somewhere else. If I build all my things in DevOps, how do I transfer that task from Azure DevOps to maybe Circle CI? I don't know. But everybody does YAML, right? So there are some differences, yes. But if I have everything in my YAML, it's very easy to port from Azure DevOps YAML to Circle CI YAML. Boom. One click and somebody can do it. In fact, Pulumi, I think I told you last time. Let's say your infrastructure is in Azure Resource Manager, ARM templates as we call it, right? Pulumi has a fantastic tool called ARM to Pulumi. So give your ARM template and it generates Pulumi code for you. So that is why I'm now looking more in terms of infrastructure as a code has to be YAML file. The actual infrastructure, let's do it with C#. Why? I can now get a dev and say like, look, take a look at this code, fix it. Because it's C#. Yeah. There's nothing else. It's like, this is a object. it needs this many. Okay, I know it. I just fill it up and then well, it works. So that's the concept that I'm trying to bring in my company, which is like we're gonna do infrastructure as a code using Pulumi with C#. We're gonna do pipelines with YAML, so that portability is easy. So those are some of the things that I'm doing, and then I'm enjoying myself more and more. I do these kind of things. It's very interesting world.
Yeah, it's really cool stuff. It's very nice. Thanks a lot.
Yeah, I don't see any other questions. So probably we already taken 1.5 hours. It's dinner time here, so hold on to anybody. So thank you very much. If you have any question, you can reach out to me on my email or ping Asi for anybody in the MSSUG, and then we'll be able to help you out. So thank you very much. I hope today's 1.5 hours was well spent.
Yeah. Thanks, Lohith. Thanks everyone for joining. Our next session is on 4th March. So you can go on the meetup.com and can register for the session. Yeah.
I have my friend from Netherlands again. So hey Roderick. So cool. Okay, so that's it then. Have a great evening, guys. And then we look forward to the part 4, which is on March 4th, you said?
Yeah.
Okay, so see you again there. Bye.
Thanks everyone. Have a good evening.